Hello students, to welcome our channel the physics point, and in these lectures we are starting discussions of the new points of the same chapter, that is rotational dynamics. In the previous lectures we are discussed the moment of inertia of the ring, uniform ring, and moment of inertia of the uniform disk. In the previous lectures we discuss what about the moment of inertia. Moment of inertia of the body of the object which can be rotating on the axis of rotations is equal to the moment of inertia is equal to the sum of mass of each particles which are present, sum of product of mass of each particles which are present on the rigid body or on that particular object, into the square of perpendicular distance from the center of or axis of rotation to that particular point, to that particular particle. This is the moment of inertia, equations of the moment of inertia. And after that we are finding the moment of inertia of the ring, uniform ring, is equal to m into r square. M is the entire mass of that ring and r is the radius of that ring. And we find the moment of inertia of the disk, that is half of mr square. This is both equations will be useful when we are comparing these both equations with the help of radius of gyrations. In these lectures we have discussed the radius of gyrations, definition, meaning of radius of gyrations, and the dependency of the radius of gyrations, and we compare the both moment of inertia of the uniform ring and moment of inertia of the uniform disk with the help of radius of gyration. Please take the heading, it is radius of gyration. Radius of gyrations. The radius of gyrations of the body about its axis is defined as the distance between the axis of rotation and the point at which the whole mass of the body is supposed concentrated. This is called as the radius of gyrations. Radius of gyrations. Radius of gyrations of the body of any object which are rotated about its own axis, not own axis, about its axis, about its axis is defined as the distance between this distance between the axis of rotation, the distance between axis of rotation and a point at which the whole mass of the body, the whole mass of the body, suppose concentrated, This is the definitions of the radius of gyrations. You don't understand by the word the radius of gyrations, then I will be drawn on the diagram here. This is our rigid body. Consider this is our rigid body. Then this is our axis of rotations. This is not exactly at the center, the axis of rotations. Then this is the distance. Consider a point at which the whole mass, the point at which the whole mass suppose concentrated, whole mass of the body एका पॉइंटला कॉन्सन्ट्रेटेड झाला असेल किंवा या पॉइंट पासून जे काही बॉसचं डिस्ट्रीब्युशन आहे इक्वली स्प्रेड आउट झाला असेल तर त्याला म्हटलं जातं सेंटर ऑफ मास. म्हणजे या ठिकाणी एक पॉइंट आहे आणि ही जी डिस्टन्स आहे, दिस डिस्टन्स इज कॉल्ड ॲज रेडियस ऑफ gyrations. The radius of gyrations of the object, its axis of rotation is defined as the distance between the axis of rotation. This is the axis of rotation. Between the axis of rotation, a point at which the whole mass of the body, which suppose concentrated. This is the radius of gyrations. The mathematically the radius of gyration कसे calculate केलं जातं? Mathematically, the radius of gyration mathematically the radius of gyration is the root mean square of distance. It is root mean square RMS, root mean square of distance of the object. Distance of the object apart, at which from distance of the object from a part, either this radius axis of rotation or center of mass. And what factors will be changes? If one factor will be changes, then radius of gyration changes. म्हणजे कुठल्या फॅक्टर वर हा radius of gyration डिपेंड आहे? Dependency, radius of gyration depends upon, this is the depends upon the first term. The radius of gyration is depends upon the distributions of mass. Distribution of mass of that object. कशा पद्धतीने इक्वली डिस्ट्रीब्युटेड झाले असेल तर त्याचं काय असणार? सेंटर ऑफ मास चेंज होत असते. कन्सिडर एक ऑब्जेक्ट आहे, या ठिकाणी मास हा रिजिड आहे आणि या ठिकाणी थोडासा पोकळ आहे. देन द ऍक्सिस ऑफ रेडियस सेंटर ऑफ मास इज मूव्हिंग ऑफ दॅट डायरेक्शन्स. देन द रेडियस ऑफ gyration हे चेंज होऊ शकतो. डिस्ट्रीब्युशन्स ऑफ मास वर देखील डिपेंड आहे. Then the radius of gyration will be depends on another factor, that is positions of axis of rotation. Position of axis of rotation. The another factors which can be changed if the positions of the axis of rotation will be changes, then the radius of gyration हा चेंज होत असतो. या ठिकाणी नाही तर या ठिकाणी जर आला तर रेडियस ऑफ gyration चेंज होणार. किंवा इथं जर आपण काय केलं, ऍक्सिस ऑफ रोटेशन सस्पेंड केलं तर काय होणार आहे? रेडियस ऑफ gyration विल बी चेंजेस. अँड अनदर वन फॅक्टर विल बी चेंजेस. त्याचबरोबर हा शेप आहे किंवा एखादा वेगळ्याच पद्धतीचा साईज आहे, शेप आहे, जे साईज आणि शेप देखील चेंज झाल्या तर आपला रेडियस ऑफ gyration चेंज होऊ शकतो. देन अनदर वन शेप अँड साईज, shape and size of object. These three things which are changeable, which are possibly changes the radius of gyrations. The moment of inertia on the factor to consider the radius of gyration, then moment of inertia, that is I is equal to m into k square. Then I is the moment of inertia of the object, m be the mass of the object, be the mass of object, and in this case the k is the radius of gyration. K is radius of gyration. This is all about the radius of gyration. What is the radius of gyration? Radius of gyrations of the object about its axis is defined as the distance between the axis of rotation, this is the axis of rotation, and a point at which the whole mass of the body will be suppose concentrated, the whole mass or center of mass. Then center of mass will depend. Then mathematical equations of that. The mathematically the radius of gyrations k or mathematically mathematical the radius of gyrations k is root mean square of the distance of that object to the axis of rotations or center of mass. These two things will be discussed here. And the dependency of the radius of gyrations, the dependent distributions of mass and positions of the axis of rotations याच्यावर देखील आपलं काय आहे radius of gyration डिपेंड आहे. Then shape and size of the object. Shape and size of the object. Consider करा हा duster आहे. Okay, not a consider, this is a must be dusters आहे. Then the center of mass of that duster is like here. Okay, या ठिकाणी जर सेंटर ऑफ मास आहे आणि इथून जर माझा ऍक्सिस ऑफ रोटेशन पास होत असेल तो डिस्टन्स आहे ऍक्सिस ऑफ रोटेशन टू द सेंटर ऑफ मास, यालाच म्हटलं जातं रेडियस ऑफ गायरेशन. जास्त टेन्शन घ्यायची कारण नाही. देन I, the moment of inertia, that is m into k square, the moment of inertia of the any object आपण या ठिकाणी फाइंड आउट केलं. Then m be the whole entire mass of that object and k be the radius of gyration. The radius of gyration is independent on the mass of that object. Distributions of mass वर depend आहे, but त्या mass वर depend नाही. Okay, this is all about the radius of gyrations. Okay, now we compare to the radius of gyrations of the moment of inertia of ring and radius of gyrations of the moment of inertia of the disk, uniform disk. Consider a disk, uniform ring and uniform disk. Uniform ring and uniform disk. Consider the uniform ring and uniform disk having the mass, having the entire mass, having the mass that is caps m and radius. It is not a radius of gyration, only radius, that is caps r. This is our ring. Consider this is our ring and this is the axis of rotations. And the mass of that whole rings, uniform ring, is caps m. That is mass is caps m and this distance is r. Caps r. And let IR is the moment of inertia of the ring and the ID is the moment of inertia of the ring, respective moment of inertia, that is m into I. That's not a Mumbai Indians, that is moment of inertia. This is not a Redmi mobiles, that is moment of inertia. IR into and ID are the respectively moment of inertia of ring and disk. Moment of inertia of ring and disk. If this is most important, now we are considering if KR. What is the KR? K means the radius of gyrations. KR means the radius of gyrations of ring and KD are the radii of gyration, radii of gyrations of ring and disk respectively. KD or KR and KD are the radii of gyrations of the ring and disk respectively. Now we know that before the starting, when I am starting these lectures, and I tell about the moment of inertia of the uniform ring and the moment of inertia of the uniform disk. Then the formula of the moment of inertia of ring, that is IR, moment of inertia of the ring, is equal to, that is m into r square, and moment of inertia of this ring in the form of radius of gyration, that is mr square. दोन्ही कसे आहेत? इक्वल आहेत. Then mm gets cancelled, then kr square is equal to r square, then kr is equal to r, taking square root on both sides. Now the moment of inertia of the disk id is equal to half of mr square, mr square. Then the moment of inertia, that is of the disk in the form of radius of gyration, is equal to m into k of d square. This is the ring kr. K of r is the radius of gyrations of the ring, and kd is the radius of gyrations of the disk. Let's cancel the same terms of the both side of equality sign. Then the half of r square is equal to kd square. Then square root of both sides. Then kd is equal to r divided by under root 2. Then the kd is must be greater than the kr. Am I right? No. The kd is must be less than the kr. Kr is the radius of gyrations of the ring, and kd is the radius of gyrations of the disk. Radius of gyrations of the ring जर म्हणलं असेल तर हे जे होल मास आहे, होल मास कसं आहे, सर्कम्फरन्स वरच कॉन्सन्ट्रेटेड झालेला आहे, त्यामुळे ते काय असणार आहे, डिस्टन्स हा मॅक्झिमम असणार आहे. जर हाच डिस्क असेल तर इक्वली स्प्रेड आउट झालेला आहे आणि याचा सेंटर ऑफ मास कुठेतरी जवळ असणार आहे. ओके, अप टू द एंडला नसणार. दिस इज ऑल अबाउट द radius of gyrations, and we are just compare the radius of gyrations of the uniform ring and uniform disk. कंपॅरिझन केल्यानंतर जे काही रेडियस ऑफ gyrations ऑफ डिस्कचा आहे तो कमी आहे ॲज कम्पेअर टू द रेडियस ऑफ gyrations ऑफ द रिंग. काय केलं, मोमेंट ऑफ इनर्शिया फाइंड आउट केलं. मोमेंट ऑफ इनर्शियाचे दोन्ही इक्वेशन्स आपल्याला माहितीच आहेत, त्यावरून कंपॅरिझन केलेला मोमेंट ऑफ इनर्शिया ऑफ दी व्हेन वी आर कन्सिडर द रेडियस is radius of gyrations, the or perpendicular distance is treated as the radius of gyrations. या पद्धतीने आपण काय केलं, या ठिकाणी प्रॉब्लेम सॉल्व्ह केलेला आहे. Comparison between the uniform ring, radius of gyrations of uniform ring and uniform disk. In the next lectures we are discuss the parallel axis theorem. Okay, now we are stop here.